Okay, friends. So, good evening, all. See, today we are going to start a fresh course, fresh topics of this advanced material characterization. And this is basically the 6 lectures devoted to the various techniques of analytical chemistry. See, during this course of 6 lecture is not that we are going to make you the master of this analytical chemistry. Basically, we are going to, because I think in the 12th class or even in your some BSc, if you are not from the chemistry background, so you might have gone through these courses actually, man. So it's just a recollections and simultaneously for those people who were not part of this chemistry group, so chemistry part, so they will be aware because they are maybe involved in the synthesis or any other material characterizations. So what are the different technique which they can exploit to characterize their materials? So this is the basic aim of this 6 lectures. And today he is going to talk about the very basics of the analytical chemistry. So how this lectures goes. This is and the today lecture content is we talks about the terminology and vocabulary of analytical chemistry. As I already told you, since I am assuming that you are from the various backgrounds, so various terminology which we are going to use very often during this course of lectures. So we'll talk about those terminology, and that is basically is a dictionary of this analytical chemistry. And then we talks about the basic overview of the analytical concept that include the solutions and their concentration and stoichiometry, because it's a very important part. Whenever any chemical reaction is going on, how to do this mass balancing of these equations, even during this reactant as well as the product, or even any during the course of reactions. Then we'll proceed towards how this analytical chemistry progress. Actually, this first comes to the gravimetric method of analysis, then volumetric titometric analysis, redox titration, and potentiometry, and then of course not today lectures, but definitely then we'll go for the spectroscopic techniques and then at the end of this lecture, going to talk about the sampling. Sampling, which is a very important part of any kind of a determinations. Because if you have done the wrong sampling, even if you are a synthetic chemist and you are making on a few milligram of the samples, and out of these few milligram of the samples, you want to given to various material characterization of the samples. So as to be very sure that there should not be that portion should not contain any hot particles. So otherwise you will going to end up with the wrong results. So let's start with the terminology of the analytical chemistry. So the first and foremost terminology in the analytical chemistry is the sample. See the material, what is sample? The material which is given to any analyst is called a sample. See, whatever the material you synthesize into the laboratory, and if you are belongs to the other part of the sciences like environmental chemistry and all, then whatever the material you collect it at the first stage, that is called a sample. And analyte, see in this analyte the element which you want to get analyzed in that sample, that will be termed as an analyte. The chemical species to be identified or quantified and can be a pure substance or a constituent of a multi-component sample. Then comes the measurement. Measurement is generally the quantity which we are going to measure it. For example, if you are going to determine the mass or the concentration, basically, then the mass is the measurement. And suppose in case of some powers or temperatures, so measurement is nothing but is a general sense refers to a physical quantity that was or will be subject to measurement. Then matrix. See, as I told you, the sample. The sample is consist of everything because your analyte is also there and all other host constituents of that particular material belongs to that thing. So the matrix is except analyte, we consider everything as a matrix. So the constituent of the sample excluding the analyte is termed as a matrix. Then comes the contaminant. What is contaminant? Contaminants is nothing but the, see, it can be analyte also. See, during the course of the analysis, if we, there is some kind of additions, unintentional additions are there, that will be termed as a contaminant. So contaminant, what is that contaminant? A substance including the analyte itself that is introduced unintentionally into sample during the collection process or measurement. Solutions, I think every one of you are aware, solution is nothing but is a mixture of a solvent and a solute. The concentration, the amount of a solute which is present in that solvent is termed as a concentrations. Then comes this metallurgical traceability. See, metallurgical traceability, you know, is the main content of this analytical chemistry. See, whatever measurement you are doing it, how you prove that the number which you have generated various analytical processes is a correct one or not. So for that, there is a, we have to trace that thing to some, you know, international standards are there. So that's termed as a metallurgical traceability. So the measurement result must be related to a reference through a documented and unbroken chain of calibrations tracing back to the SI units of measurements. I think all of you must be aware what is the SI units of measurements. So there are 7 basic SI units of measurements are there. So if you see, for example, because we are going to speak about these material characterizations only, and my part is only the chemistry portions. So we are going to worry about the, either we are going to determine the mass or moles, the amount of substance in terms of moles or kilograms. What is metallurgical traceability? See, metallurgical traceability means measurement can be meaningfully compared across different places at different times by different people using different equipments. See, for example, if I have done given samples, for example, I have taken an alloy and I have to determine the amount of a copper in that. So that alloy sample can be analyzed by here at Mumbai, whether it analyzed at Delhi, or whether it be analyzed at the New York, or maybe at any other European city. So the concentration must be the same only. So how will you prove so that there may be so many errors will be introduced in that. So for that purpose, there is a called a metallurgical traceability. So whenever we are doing any kind of a measurement, so we have to do a determination of a standard reference material that is called a other CRM, certified reference material, or a SRM. So there is a 7 basic units, and as I told you, as in a chemist, we are mostly looking for this mass, which in kilograms, or the amount of substance in when we doing the determination in terms of moles. Then comes the blank measurement. See, blank measurement is again is a very important term. See, blank measurements means this: if you are doing any kind of determinations, so that analyte should not come through your processing, because while doing the processing of the sample, we are mixing many chemicals during the course of analysis. So that analyte should not be introduced by that thing. So what we do there, we carry out a blank measurement. Blank measurement means that sample the processing step should not consider the sample. Except sample, everything will be there in there. All these steps will be taken into consideration when we do the blank measurement. Then biasing. There is sometimes, you know, there is a lot of biasing. Biasing is because of the not unintentional biasing. Intentional biasing is because of unintentional reasons. They be maybe, you know, your way of looking to the instrumentation or your way of processing that thing. So that's the difference between the expectations of the test results and the accepted reference value. Because as I told you, whenever we are doing any kind of measurement, we must do the measurement of the certified reference material or the standard reference material. So the difference between the expectation of the test results and accepted reference values will be termed as a bias. Then standard. See, you must be, you know, whenever you do, you give any sample for, you know, any determination of any elements, then the analyst say that, oh, I do not have the standard. So basically, standard is having a non-compositions containing the analyte and prepared from a certified reference material, because so all the standard reference standard materials standard solution means there are standard materials are available in the markets. So one has to prepare it. Either you have to prepare it in laboratory or purchase from the market. So that's called a standard of that particular analyte. And mostly these materials, standard solution has been prepared from the standard and prepared from a certified reference materials only. Then comes the primary standard and the secondary standard. Primary standard is substance that is extremely pure, stable, has no water of hydrations, and has a high formula weight because it considers a most stable element. So we will see that during the course of the lecture what are those elements like calcium oxalate, sodium carbonate. So there are some of the standard material, primary standard materials are there. And secondary standard is standard that is prepared in the laboratory by a third party for a specific analysis. It is usually standardized against a primary standard because the secondary standard is prepared by the use of the by using the primary standard. Then comes the spike. See, there is many times we say that okay, you are not getting results. You please do the spiking. So what do you mean by spiking? This spiking is a two type of spikings are there. One is the internal standard or a standard addition. See, internal standard basically there is usually. कौन है वो सी? Nothing, na? Okay. So basically, there's a difference between the internal standard and the purpose of using the internal standard and standard addition as an entirely different one. The internal standard generally we are adding to see the performance of the instrument or performance of the calibration or performance of the instrumentation. So basically, the internal standard should not be the analyte which you are going to do the analysis. Maybe some other elements. That too prepared from the standard solutions only. So we see that if I'm analyzing that element, the other element which I added as an internal standard, that also should be very close to the standard solution, the value given in the standard solutions. And standard addition, the purpose is entirely different. See, sometimes we want to see any kind of matrix effects, okay? Because of the matrix, my signal or whatever the signal is there in terms of intensity is either getting enhanced or subduced. Then I have to add the standard addition of the same element which I am analyzing it. So if suppose if the concentration is X, if I am getting X plus 1, so it means that there is some similar element is present in that matrix. If I am getting X minus 1, that means that because of some chemical reaction, my signal is getting subdued. So there is a different purpose of the internal as well as the standard, internal standard and the standard additions. Okay. Then comes the technique, methods, procedures, and protocols. See, technique, what is technique? See, whatever the analysis we are doing here, any chemical or physical principle, we can use to study and analyze that termed as a technique. And methods, application of a technique for a specific analyte in a specific matrix. See, this is very important. Specific analyte. For example, if I'm using a copper in a soil sample, it means that I should have a copper in a soil samples only, or a copper in any particular alloys are there. For example, any particular alloy is there, then that method is valid only for only for copper in that particular matrix only. Okay, and it's basically considered as a logical sequence of operations and generally described use for the performance of measurement. Then comes the procedures. Procedure is nothing but a set of a written direction telling us how to apply a method to a particular samples, including information obtaining sample handling, interference, and validating the results. First, we will see that how to validate the results in the process. So everything comes under the part of the procedures and protocols. See, whenever you are doing any kind of analysis, see, everybody will ask you, suppose if you are doing the analysis for any, any law enforcement agency or any others third party, they will what kind of protocols are being followed by you. So protocols is nothing but a set of stringent guidelines specifying a procedure that must be followed if an agency has to accept the results. Okay. So this has to be clearly said that this kind of protocol has been followed, and everything will be become standard operating procedures. So all those things will be very clearly mentioned in your standard operating procedures of that particular analysis. Then there's a two kind of analysis are there. One is qualitative analysis, other one is a quantitative analysis. See, the qualitative analysis, as the name says, see, only if I am interested that if this element is considered zinc, cadmium, copper, barium, and lead, then if I am only interested that these are the elements considered in this particular matrix, and my interest is that only, so that will termed as a qualitative analysis. But when I want to know what is the amount of a lead, cadmium, copper, or lead into that particular matrix, then we termed as a quantitative analysis. See, there's a two kind of analysis, total analysis technique and a concentration analysis technique. What is the total analysis technique? A technique in which the signal is proportional to the amount of analyte, the total amount of analyte which is present in your sample. So that is termed as a total analysis technique. Whereas a concentration analysis technique, technique in which the signal is proportional to the concentration of analyte. See, in general, there's a two terms which we analytical chemists mostly use: these parts per million and parts per billion. Of course, as per the new IPAC rules, we should be avoided as far as using this ppm or ppb. It should be given either in terms of a microgram per gram in case of a ppm, that or either milligram per kg or milligram per liters. Whereas the ppb, that is the parts per billion, should be denoted as in nanogram per gram, microgram per kg, or microgram per liters. Then see, whenever you are doing any kind of analysis, this is a detector. What is detectors? I think most of you are, since you are doing a material characterization course, must know what is detector. A detector is a device that responds to the presence of analyte, and generally what it do, it gives an electrical output, electrical signal. And signal, the detector output that displayed or recorded that termed as a detectors. See, sensitivity. See, each instrument having has been, what is the sensitivity of the instrument? This is a general question that had been asked. The sensitivity of the instrument is basically a slope of the calibration curve. Okay, so slope of the calibration curve is that, see, whatever the y-axis, whatever the x-axis you are doing determinations, so how the y-axis, how sensitive is your y-axis? So that is the slope of the calibration curve is termed as the sensitivity, and signal to noise ratios, as the term says, the ratio of the signal to the baseline noise. Then again, this important question: what is the dynamic range of your instrument? See, dynamic range is nothing but the maximum or a minimum. So, what is the maximum of an instrument? When the signal is not proportional, no longer increasing with the increasing in the analog concentration, that is we termed as that maximum determination that particular methods or procedures or by that instrument. And the minimum is generally considered as the instrumentation limit of detection. That is, the instrument cannot determine less than that values. So that is termed as a dynamic range. That is the range of a maximum to the minimum measurable signal. Then method development. See, basically these are some of the important part of the whenever we discuss about the QA/QC. See, determining the experimental conditions, which include sample collections, preparations, measurement, and produce a accurate and a repeatable results. That is called termed as a method development. And method validations, performing control experiments. Okay, see, suppose you have developed any methods, and how you will prove that the method which you have developed is correct one. So that is done by the method validation. So for the method validation, you have to take the standard reference materials and do the similar type of steps, perform the similar type of steps. So performing control experiment to verify the accuracy, sensitivity, specificity, and reproducibility of the test methods. What is it? There is a two important terms. See, the quality assurance and quality control. See, these are the two different meanings are there. See, auditing of method and procedure termed as the quality assurance, whereas the quality controls procedure of instrument calibration and method validation to produce accurate results. See, basically, this quality assurance is a responsibility of the administrator of that particular laboratories, whereas the quality control mainly maintained by the analyst himself. So these are the responsibility of administrator to see whether the proper quality assurance has been taken and whether the quality control mostly taken care by the analyst, and definitely it is monitored by the administrator also. Then protocols, as I told in the just before 2 PowerPoint, is a set of stringent written guidelines specifying an exact procedure that must be followed before an agency will accept the results of analysis. And a protocol contain explicit instruction regarding see, there is a two kind of a quality control and quality assurance and quality control. One is the internal quality controls and quality assurance, and one is the external quality control and external. See, both are having its own importance, but generally the internal quality control is done by the by the third party within the laboratories, whereas the external quality control is managed by the external agency. So in India, there is a one agency appointed by the government of India that is called as a NABL, National Accreditation Board Limited, which do the external QA/QC for the particular laboratories. And then if it has been done by that QA/QC is performed by the NABL, then your laboratory will be termed as a compliances with the 17025. See, method blank, as I told you, there's a process blank. See, process blank include the standard and a samples. Since during the preparation of the standard also we are using it we are using a deionized waters and some other acid to make this standard solution or dilution if we are doing it. So that what we do it, see everything except standard, then it becomes as a method standard blank, and other is a sample blank. That is you are doing the all processes except your sample is not there. So this called a standard as well as a standard blank and a sample blank. Instrument blank, see, basically whenever we are doing the determination of any intensity or doing any measuring area absorption at a particular wavelength, at that particular wavelength also instrument may be having some kind of a signal as there. So that will be termed as it has to be taken care if you are doing any kind of measurement at 330 nanometers. So you must see that because of the some digital issues, some signal is not coming, some intensity is not coming in that particular wavelength. So that will be termed as an instrumental blank. Then, see, before doing any kind of analysis, one has to prepare a calibrations curve. So what is the calibration? The process of measuring a known quantity. What we do, how we make a calibration curve, that we make a different, concentration of the concentration by using standard solutions, and then measure that particular signals at the different amount of different analytic concentration. That's how we make a calibration curve. See what is the figure is showing that basically we are performing a calibration curve for the mercury. Okay. So that is basically we are doing the determinations, calibration curve for EDXRF spectrophotometer for determination of amount of mercury. So different concentration of mercury is used in the samples, and that's how this calibration curve has been done. And then equation has been a linear fit equation has been calculated, and on that basis, if you are doing any unknown sample concentration and measuring the amount of by which we will know the amount of the mercury present in the unknown samples. See the limit of quantifications, the concentration, the lowest concentration that can be determined with acceptable laboratory reproducibility and trueness, and the limit of quantifications from the lower level from measuring range. So that's how we have finished this analytical terminology. Is there anybody there? Boss, कोई है क्या?
Yes.
Hmm. First, can you unmute yourself, and if you are not able to understand anything, can you tell me so that whatever the terminology I make you, whatever explain you up to now, if any problem is there, you can come out and then we can discuss. नहीं कोई नहीं है क्या अनम्यूट है if any question is there. ये अभी हैं क्या if anybody is having any question you can write in your chat box also. See, it's really very nice if it is a interactive lectures actually. See, because now almost I am retired, so almost I work here 35 years in this field. So for me, many things will be very journal. But when you ask some question to me, then I will be, and then I go on speaking on the flow and whatever my understandings are there. So if you can ask me some question, then we can think and then explain you if you are not able to understand that term properly. Because I think whatever I told you up to now is very important. Whatever the field you are concerned, and maybe if you have not been getting a job, so whenever you are going to appear for any interview, see these are the general questions has been asked. Which instrument you have worked in? If okay, I work on this particular instrument. So, for example, what is the resolution of that? Suppose if you say that XRD, what is the resolutions? And what is the minimum and maximum angle? Through the angles are there. What is which detector had been used? And how the signal had been generated. So these are some of the common questions being raised during this course of any Viva or any kind of a job interviews. Now let's see what is the analytical chemistry. See, analytical chemistry basically start with the sample collection. Actually, my sample collection is also part of the analytical chemistry, but generally the sample had been given to analyst. If the sample has not been given to the analyst, then he has to collect it himself also. Since being I am an environmentalist and most of the sample whatever is there, so environmentalist has to collect their own samples and then do the analysis. So that's why I include in this particular lecture these processing also, the sample collection, processing, and then separations, identification, and quantification of the chemical component of natural as well as the artificial materials. So this is the broad definition of the analytical chemistry. So analytical chemistry is the study of processing, separation, identification, quantification of the chemical component of the natural and artificial methods. So during this course of this 6 lectures, we will proceed like this only. See, we'll do the first, we study the the sample collections. See, after doing the initial basic understanding of the analytical chemistry, we start with the sample collection, processing, then separations and identification and the quantification methods. Actually, different quantification methods which we are going, which we had studied it. So the classification of the analytical chemistry, basically the all the techniques of the analytical chemistry has been divided broadly into the 3 main classes, that is called the absolute methods, a relative method, and a comparative method. What do you mean by the absolute methods? See, absolute methods are those methods which does not require any kind of a certified reference material. See, without using the certified reference material, And if I can, if I can tell with 100% confidence, yes, this is the elements present, so this will be termed as a absolute method. And for example, the determination of sulfate by adding the barium chloride, then we do the determination by using the gravimetry. Similarly, determination of calcium using the titration, that if we are doing the by 0.1 EDTA solution, all those, these two techniques does not need any kind of a CRM, no CRM is required, no calibrations, no calibration with standard solutions. See, you don't have to use the various concentration of the sulfate and then do the determination by the barium chloride method. No need. Whatever you are determining it, they are considered as a, they does not need any kind of a calibration, these ones. So the classical methods of gravimetry, volumetry, and instrumentation technique like coulometry, because again coulometry you are doing the determination of mass, and isotope dilution mass spectrometry technique are considered as a absolute methods. So absolute methods are those methods which does not need any calibration, no CRN, and they have their own. They can determine the concentration, how the concentration can be determined. The concentration can be computed directly from the stoichiometry of the chemical reaction. One question is, sir, can you please clarify the difference between Q and QC? Yes. See, already, what is name? Amit, already I told you, see, QA is a part of the administrator. See, basically the whatever the procedures and methods you are going to apply it. So before analyst, those method or procedure given to analyst, it's a duty of the administrator. So that is the part of the quality assurance. The quality assurance is done by, for example, if you are a student and and your guide is X person is your guide, so the QA has to be maintained by you X. Okay, and QC, because quality control, which is you looking for the instrumentation part and the processing also. So that is a part uh, of the analyst actually. So QA is the part which is maintained by the administrator, where the QC is only controlled by the person who is performing the analyst. And of course, when the analyst, whatever the activity analyst has been done, that also has to be, while doing the internal auditing, the QA will question and monitor that also. So that is the, so QA is a maintained by the administrator and QC is by the responsibility of the analyst. Amit, I'm clear? Okay. So that so we have seen that in case of a absolute method are those methods which does not need any kind of a calibrations. They don't need any kind of a CRMs. Only the by following the chemical reaction and then through the stoichiometry of the chemical reaction, one can tell the concentration, what is the amount of the analyte present in the sample. So they will be termed as a absolute methods. Okay, that is the term say that absolute means that they are not depending on anybody. Then there comes up the relative methods. See, in case of a relative method, you have to prepare a calibration. See, until unless you are using an instrument, for example, if you are using an atomic absorption spectrophotometer and you are measuring the intensity at a particular wavelength, see, instrument does not know that what you are measuring, whether you are measuring it's a copper, whether you are measuring a cadmium, or whether you are measuring a zinc. So it is only the calibration curve. You measure, you prepare a calibration, you prepare a calibration curve using a standard solution of a cadmium or zinc or copper. Then only and then you do the determination of the unknown samples. So through that, until you have a calibration curve, you can't determine the concentration of the unknown samples. So it depends on the calibration curve, and that calibration curve has to be prepared by the ACO standard, and those ACO standards has to be prepared by using the standard solutions. So that's how they, so the relative method, basically you have to prepare a calibration curve. And again, in that calibration curve also, when you are preparing it, so because as I told you, you are using a atomic absorption spectrometer, then you have to see that any variation, that condition should not vary. The sample run under identical conditions. See, whatever the way you had measured the concentration of the analyte in the standard solution, the same way you have to measure it in the your sample also. What is the condition there? We should not change the fuel or oxidant ratios. That flow rate, that is the flow rate by which the sample introduced into the nebulizer, that also should not be changed. And the sample concentration. The sample concentration means that if you prepare a, for example, if you are determining the concentration in the ppb range, and you cannot take this the standard in the ppm range. So your standard also should be in the ppb range only. So that's why the proper calibration only give the excellent results. So that's how they termed as relative methods. And then we'll see that slowly what are those relative methods are there. Then comes the comparator method. So what is the difference? The comparator method, again, they depend on the calibration as well as the standard materials. But the difference between the comparator methods and the relative methods is that in case of a comparator methods, you need a matrix matching standards. It means that if you are determining the copper in the soil samples, then you need a standard of the soil only. If you are determining the copper in any alloy sample, so in the steel, then you determine the standard of the steel only. So that is the difference between the comparator method and the relative method. So relative method, you can make the reference material or without bothering the matrix. But in case of comparator method, it is absolutely necessary that you prepare a calibration curve using the matrix matching standard. Matrix matching standard means, see, if you are measuring any element in any particular matrix, for as I told you, copper in the soil, copper in the steel, then you should have a standard also of that, either of the steel or in case of soil, you should have a soil only. Similarly, if you are doing any kind of a measurement in the water samples, then again you have a similar kind of a matrix matching standard should be there. So the comparator methods, what are those comparator methods like XRF, OES, the X-ray fluorescence, optical emission spectroscopy, or neutron activation analysis? So matrix matching is essential. Experimental conditions should be identical for sample and standard, and the sample concentration should be bracketed by the standard. See, whenever, for example, if you are given any sample for the for any kind of analysis, so how the analyst chosen a technique actually, I mean, that depend on the, so what are these are the different thing he will what are these are the different parameters you will see. We will see that it should have accuracy, precision, sensitivity, selectivity, robustness, ruggedness, scale of operation, and analysis time and availability of equipment and cost. See, the last two part is also very important one. Suppose if you are doing any kind of analysis, if you are doing this any determination in the percentage levels, then even there is no need for you to go for any sophisticated equipment. Even a simple XRF will be, good enough for doing your measurements. But if you are determining in the range of a nanogram per gram, in the range of a ppb, then you need a very sophisticated equipment as well as the processing should be such that there should not be any addition of that particular analyte by during this sample processing. So the main analytical technique which was used to determine the different inorganic species in the classical methods, like I told you, gravimetry and titrations, flame photometry, UV visible spectrophotometers, and then atomic absorption spectrophotometer. The atomic absorption spectrometer, we say that if it is a flame, then we say this FAAS, and if it is considered a graphite, then we say that GFAS. Then inductive coupled plasma atomic emission spectrometry. And inductively coupled plasma, see, there's mainly people get confused. See, nowadays ICP AES or ICP OS, there's a difference. See, ICP AES people used to use in the prior days because late 90s. Actually, may this the emissions to the oils are not been included. But nowadays, the emissions due to ions also have been treated. So this now ICP, whatever the AES is, atomic emission is there, now it's called a inductively coupled plasma optical emission spectroscopy. Then we have inductively coupled plasma mass spectrometry. See, if you see most of the 40% to 50% determination has been done by these three techniques: atomic absorptions, spectrometry, or ICP-OES, or then ICP-MS. Then we have a neutron activation analysis, X-ray fluorescence, and ion chromatography. See, already I written on the top of this PowerPoint that this is, I am talking about the determination of the inorganic species. So these are the technique which we use for the determination of the inorganic species in the various matrix, whether it's a synthetic origin or whether it's a natural origins. Then these next few PowerPoint is only, just giving a glimpses of, the chemistry which you might have read in your 10th and 12th class, that is solution, stoichiometry, and a chemical reaction. See, whenever any chemical reaction is there, you must be knowing it's involved a reactant and a product. Okay, so any point of time, if you want to know the concentration of a reactant and a product, or a concentration of all this constituent of a reaction, then you need to know the stoichiometry. So basically, by doing this stoichiometry, we will come to know the concentrations of the reactant and a product at a various stage of a reactions. And generally, what we talk about this determination of concentration has been done by using either the titration that in the next few PowerPoint, we'll see that all these acid-base titrations, then redox titration, and the complex precipitation titrations are there. And in all cases, the reaction chosen for the analysis should be whatever the reaction you choose, it should be fast and complete and specific. So that is the only the compound of interest should react with the titrant. And during the course of this titration, the equilibrium point is reached when a stoichiometry amount of the titrant has been added to the amount to react with the unknown. See, the solution, as I told you, that it's a reactant and a product. So this you can determine the concentration either in terms of moles or in terms of grams per liters, whatever the way you want to maintain the stoichiometry of a chemical reaction, you can go ahead with that thing. Then we'll see certain example of these chemical equations. See, this is basically, maybe you have done this kind of a work maybe in your 10th class or 12th class, so might have forgotten. So that's how just to, remind those things. See, the state of a reactant and a product generally we write in the parentheses to the right of each compound. And the coefficients have been inserted in the chemical reactions just to, balance the equation. So that's how this reaction particularly is showing that how the methane react with the oxygen to give the carbon dioxide and the water molecules. So this is how the balancing of the equation has been done. So the state is written in the state of the reactant, the physical state of the reactant has been written in the parenthesis. See, for example, sometimes you see that instead of G it's written as S, so it means that solid. And if it is L, then it's written as liquid. So those basically again this is stoichiometric calculation which showing these the hydrogen react with the oxygen to give a water molecules, and these terms we can do the atomic mass unit or in terms of moles or in terms of a grams. So again here the coefficient in the balance equation give the ratio of mole of a reactant and a product. So you have seen that the 2 moles of the hydrogen react with a 1 mole of oxygen to give a 2 mole of a water. So this is the what I told you in case of absolute method. So what is the this main advantage of the this absolute method is that, see, basically, I think we are not introduced the terms of this RSD, actually relative standard deviations. See, whenever you are going to determine any kind of determination of analytic in any matrix, this relative standard deviation is one of the important. And in general, we are getting it about a 5%. But absolute methods means the gravimetric methods are only those methods where the RSD is less than a 1%. So there should be only 1.5 to 1%. It means that the results are very good one and an accurate one. And there's again, because the sampling is clearly indicating that there is a low sampling error, no matrix effects, and both the classical method of gravimetry and volumetry satisfy this criteria. But again, they are not free from the interference. So what kind of interference? We'll see that while doing the gravimetric methods, what are the interference are there. And it's very essential, because nowadays so many instrumentation it comes and everybody want to determine the just intensity analyte. But for doing the gravimetry analysis, one should have a very good knowledge of the chemistry. So until unless you know that if this reaction I will perform and this will precipitate it, you will not be able to do justice to the gravimetric analysis. So one should have a very sound knowledge of the chemistry when he has to implement the absolute method for the analysis. Since there are certain examples that the estimation of a chloride by reaction with the silver nitrate solution. So we have a precipitate of the silver chloride. Then phosphate by reaction with the ammonium molybdate. Nickel determination by DMG. I think most of the nickel determination by DMG we had done in case of a 12 class practicals. And rare earths by oxalate precipitations, this generally even we perform in our Department of Atomic Energy. Also, a lot of rare earth determination still has been done by the these gravimetric methods by oxalate precipitations, and uranium determination as a uranium oxides. And the main important part whenever you are doing the gravimetric analysis, so the precipitation should occur, and when precipitation occur when the precipitation occur when the solubility KSP should be higher than the concentration of the barium sulfate. A precipitate is obtained when KSP is exceeded either by KSP is exceeded, and how this solubility product constant is exceeded, either we can increase the ligand concentration or increase in the free ligand concentration by increasing the pH. So these are the few determination of the potassium, magnesium, calcium, barium, titanium, rhodium, chromium, manganese, iron, cobalt. So these are the various elements which we can determine by using the gravimetric methods. But again, if you see that all these gravimetric methods, these are so many interferences also there. So how it's again you should have a very sound knowledge of the chemistry when you doing the using the absolute method, and sometimes it becomes very necessary to use only the absolute method because the authorities say that they need a RSD value less than a 1%. See, if they say that you need an RSD value of less than a 1%, then there is no option left that you have to determine the concentration by using the volumetric, by using the gravimetric methods. But again, there's one more important part is that gravimetric method only will be done when your element of interest is present in the percentage levels only. See, if it is a very small amount of analyte is present, then you cannot perform the cannot do the gravimetric analysis. So what are these are the drawbacks of the gravimetric methods? Co-precipitations. So many we have seen in the last PowerPoint that so many ions will be co-precipitated when we are doing the precipitation. Co-precipitation means the other element will be precipitated when the main element is getting going on precipitations. So that is called a co-precipitation. Sometimes incomplete precipitation of the element of interest is there. Then after doing the gravimetric analysis, because it's a wet chemical, so you have to do the drying by using by heating it, and then at that time there is a losses actually. So this losses during washing, drying, etc. And then these required, as I told you, knowledge of condition of proper precipitation, drying, and measurement. Applicable to a large sample size. Taken time for the analysis is long, and procedure is rather tedious and applicable only to limited number of analytes. So these are the few drawbacks are there. So to cover this drawback, what the all this volumetric analysis come into the pictures. So the limitation of gravimetric methods lead to volumetric methods. So the volumetric methods may what we can see that the acid-base titration, oxidation reductions, and then the complexometrics titrations are there. So these are the some example when you're doing the determination of the this acid-base titrations are there. So this is example I have given here, the determination of a calcium hydroxide. See, basically what I'm doing the titration of hydrochloric acid by neutralized by using a calcium hydroxide. So what is the concentration of the alkali means what is the concentration of alkali? What is given to me is I use the 25 ml of a 0.5 ml hydrochloric acid. So the volume consumed the calcium hydroxide is, so how many moles of the calcium hydroxides are there? So this is just use this mole triangle. So what we can see from this reaction, from this equation, that the 1 mole of a calcium hydroxide use the 2 moles of HCl. So we use the stoichiometry of the reaction and then calculate the number of moles of a number of moles of a calcium hydroxide, and then so this is how we can calculate that the 0.0625 moles of a calcium hydroxide will be utilized in utilizing the 2 moles of a hydrochloric acid, having that concentration 0.025 ml. Similarly, in case of redox titration involves solution of a reducing and oxidizing agent, and the volume of a reactant solution required to complete the reaction is determined by titration. In a redox titration, precisely enough electron have been removed to oxidize all of the reducing agents. And this is an example given of this, the iron chloride react with the sodium dichromate. So we can see from this equation that the 6 moles of the of iron chloride and use the 1 mole of a sodium dichromate. So now we will come, what is given to me, the 330 ml of the iron chloride had been having a concentration of 0.415 moles of per liters. Sodium chloride had been utilized. So the number of moles of the iron, we can calculate it by using the again that Passer triangle equations. So this is the how we will come to know the number of moles of it and using the also balance equations. So 0.3 moles of the iron chloride had been utilized of the 1 mole of the potassium dichromate. See, these are some of these basic things which have already been done, but since I make you to completely taken you back and to the chemistry level, so that's why I'm discussing these two oxidation, acid-base titration and the redox titration. Then comes to this important points again for the doing this selection of an indicators. The equivalence point and end point should be close together, and how will make sure that the equivalence point, I think you must be aware what is the equivalence point and the end point. See, end point is basically for the change in the color of the indicators, and equivalence point is that when the concentration of the two, whatever we are using in the reaction, they having they matching their stoichiometry. So the equivalence point and end point should be close enough. So how we can make sure that it will be only pK value of the indicator is close to the pH value in the inflection region. So that's how we choose the indicators. And indicator we should not add in the to minimize the error, to minimize the, because that indicator is not taking part in your chemical reactions. It's only reacting with the titrant. So indicator should the quantity of the indicator should be minimum as much as possible to avoid indicator error. And endpoint can be detected. Endpoint can also be detected by the colorimetry because there is a color change in the reactions there. So this is some example of the oxidation reduction method. Ferrous in presence of potassium permanganate in sulfuric acid solution. Ferrous ion get oxidized. Similarly, in case of that, what is happening to magnesium, which in the sixth state is getting reduced to magnesium second. And when magnesium both is formed, if the solution is neutral or basic, the nature of the reactor is controlled by the acidity. The other examples of the hydrometric using this sodium thiosulfate as a titrate and starch as an indicator. And we can do the estimation of copper in alloy or in complex of copper or iron with, with oxalate. There is certain example of this, complexometric titration, that is complex of EDTA with high stability. I think most of you are aware what is EDTA. In general, EDTA form 1:1 complex. Here the calculation is much simpler. The control of pH affords selectivity because by controlling the pH of the reaction, we can control the selectivity. And there is a relation between the log K of a complex, whatever the complex is, so that is stability constant of that particular complex, and pH need for the titration. And stability constant depend on the ionic potential of the metal ion, which we are going to place it. And stability is high for highly charged ion as usual. For example, in this case of iron, thorium can be titrated at low pH, whereas nickel and copper at pH 6. Of course, these are when you do in a practical terms determination of these things, you will come to know. But more important of this last few PowerPoint is that you will how these the whatever the drawbacks which we are getting in case of a volume in the gravimetric analysis has been overcome by using a volumetric titrations. And volumetric titrations, we learned that acid-base titration, then the redox titrations, and then complexometric titrations are there. Then there is a features of EDTA titration. This is generally when we are carrying out this general features in when we carried out this EDTA titration. See, then comes this calorimetric methods. See, calorimetric method as the word says that there is a change in the color, and one can measure the whatever the change in color, you can measure it. So then we can depend on the depend on the concentration. For example, determination of iron with thiocyanate. See, you may be knowing that whenever iron react with thiocyanate give a blood red color, and then the intensity of that by different concentration of the iron will give a different kind of intensity of this red class. Then the reaction of ammonia with an escalation, this is still a very typically has been used even in our, many of the plants also. The determination of ammonia by the Nestler region, but since now this Nestler region contain the mercury and now mercury has been avoided as per the, international's laws are there, they discourage of using mercury. So that's why it has been now looking for another alternate way of determination of ammonia. But determination of ammonia with escalation is one of the most practical, even in the late 20s. Then determination of nitrate with digestion, coupling to form a dye. An advantage of that because they are very selective methods, and even a very low concentration, they give a very nice color and can be determined. And the procedure is a simple one. So these are the certain advantages of using these calorimetric methods are there. And some of the example of the calorimetric application, the determination of lead in the water, hemoglobin in the blood samples, glucose in the blood, nitrate, manganese, iron, etc. in water, and even different kind of annihilated trace level in different ores, and some of the pharmaceutical compound also, because I have not taken those examples here in this PowerPoint, because there are many pharmaceutical compound will be very nicely determined by using this simple calorimetric application, and the results are very accurate one, and it will be well accepted also. So before starting the next part, if any queries to anyone by anyone. Well, they are listening now. If any type of queries are, please write down in your chat box. See, even if I am not able to answer your question, because there are many, I will try to go back and then look about the answer section. But I will be very happy of interacting with the students actually. Any questions related to even from the, your day-to-day life of chemistry, I will be very happy to answer. It's not necessary that, whatever the problem you are facing in your day-to-day analytical work, if you have written any kind of manuscripts, there are many questions comes from the reviewer, how you have performed the analysis. Whether you have performed the QA QC on your whatever the determination you have done, whether QA QC had been performed, these are general question has been asked. Even if you are a synthetic chemist, so how you determine the concentration of your elements in the by which technique. If you say that this particular I have determined the determination by this atomic absorption spectrophotometer, for example, there are certain elements are not sensitive to for determination by these atomic absorptions, and you just say that I have determined by atomic, so you will be just uh, you will come to know that somebody else has done the work for you. Any type of questions? Okay. I think there's a time lag also between the YouTube and us. 10 seconds. Only 10 seconds? ठीक. कुछ है क्या? Okay. Amit, see robustness and a ruggedness. See, this is basically, what is that English terminology are there? See, robust technique means that, see, you do n number time of determinations. Okay, so you are going to get the same kind of results, again and again. So that means that technique is a very robust one. You cannot challenge the technique. So for example, if I say that determination of a silver by gravimetric method. So silver is a robust technique for determination of gravimetry is a gravimetry determination of the silver by precipitating a silver chloride precipitate is a robust technique. If I determine the silver by using the any others, for example, of course, I have not done so much determination of silver by using these AS. I think it is sensitive to ICP OES. If I do that, so I will not consider it a robust technique for determining the ICP, because in ICP-OS I will get the some or other variations are there. But if I do the same time determination in this thing by using the gravimetry, so it's a robust as well as a rugged technique. Rugged means this means robust, and a rugged means that it does not depend on the variation in the natural fluctuation. For example, it should not getting varied because of with respect to the moisture in the laboratories, or due to the temperatures variation in the waters, or maybe for example, there are so many particles are present in the so they are called a robust and a rugged techniques. I hope, Amit, I am clear. Okay. Hmm. Shall we start? नहीं. Okay. See, as I told you, sampling is one of the very, very important criteria of doing any kind of measurements. See, if you are not collected the sample properly, then whatever the sophisticated equipment you are having, whatever the best analysis you are having, your results is definitely going to get a erroneous one. And whenever we do the sampling, these are the general, as you say, as we have seen that robust and a rugged technique. So similarly, whenever sampling is there, people will ask this question whether your sample is representative. If it is representative, whether it is homogeneous. So what is the meaning of a representative and a homogeneous sample? See, basically, if you are a synthetic chemist, then you may not have a much meaning of a representative sample. But if you have done a bulk synthesis, then there is a meaning of a representative samples. See, for example, whatever the bulk synthesis you have done it, then you are not going to give the full 1 kg of the samples to the analyst for the analysis. So you will just select a small portion of that particular material which you have synthesized it to the analytical chemistry. So that particular portion should represent the whole content of your bulk samples. So that is the meaning of a representative. So representative means that the content of analytical samples reflect the content of a bulk samples. What do you mean by homogeneous? See, homogeneous means that particular, suppose if you are interested in a particular analysis only, see, if you are interested in that the synthetic material, you have prepared it. Okay, you have prepared any kind of a drug, you have prepared it. And in that drug, zinc is a very important phenomena, a very important part. So the concentration of the zinc should be there in the whole bulk sample should be same. See, I sometime back I used the word of the hot particles. See, there may not be any, because of any wrong procedure, because of your any wrong processing, you should not have developed any kind of hot particles. Okay, see, hot particles means that the concentration in that particular the content of the zinc in that particular portion is very very high. So that is called a meaning of the hot particles. So homogeneous means that the analytical sample has the same content throughout. So this is the two very, very important terminology which we consider in case of a representative sample and a homogeneous sample. Suppose if anybody of you belongs where you are doing any kind of a work in the area of environments, then it's very important to take a representative sample. See, in environment means I am looking for example, this area of a Mumbai regions, and I say that the concentration of the copper in the soil of a Mumbai soil is having a some X microgram per gram. But see, the Mumbai region is maybe 100 square kilometer of area, but how you will say that doing this some 10 analysis that Mumbai soil is having a 10 microgram per gram of a copper? No. So for that you must be have a representative sample. Representative samples means you will collect a lot of you make a grid of this 100 square kilometer of area, and in that grid, in that particular grid samples, see, suppose if you are grading over some 1,000 grid, you are created it, okay? And in the 1,000 grid, you will collect the samples, and then this 1,000 grid again, because you cannot do the analysis of the 1,000 samples. So what you will do it, you will bring into the laboratory, mix them thoroughly, okay, and make it 100 samples. And those 100 samples should be give a representation of your 1,000 samples. So that's how we say that it's very important to have a representative samples as well as the homogeneity. So these are the two very important terms as well as the sampling. Consider that my sample should be representative as well as the homogeneous. Then what are the deciding factors? The deciding how to obtain a sample for analysis depend on the size of the bulk to be sampled, the physical state of the fraction to be analyzed. See, what are the mostly samples, either of the solid, liquid, or a gases? These are the basically three state of materials. Only we generally use it for for taken for the analysis. Then the chemistry of the material to be assayed, and see, the thing can be done that would destroy or alter the identity of the analyte. See, for example, if you are performing any sampling or anything which destroy or alter the identity or quantity of the analyte, then you can't help it. Rather, you cannot proceed it, because if your analyte itself will be get change the concentration or destroyed while doing the sampling, then on the spot determination is must. I'll tell maybe I'll give you one or two example. What is the meaning of this word? Nothing can be done that would destroy or alter the identity or quantity of the analyte. So a chemical analysis usually performed on a small portion of the materials to be characterized. So as I told you that it's not necessary that if you are 1 kg of the sample, you cannot do the determination of the 1 kg of these whole samples. And if the material is very small and is need for further use, then the entire sample may be used for the analysis. This is only possible, but generally, we have seen that even in some of the synthetic cases, synthetic chemists, they make a very small, about some 100 milligram or 50 milligram of the samples are there. They are very much afraid that, all the analysis. See, generally, what we, the minimum quantity what we need it in case of for example, in case of an environmental sample, we need a minimum 100 milligram of the samples. But if a synthetic sample is there, then even the 2 milligram of the sample will be sufficient for doing the determinations. Because your sample concentration is very high, and even whatever the kind of a dilution, I can perform dilution on that thing. So a small quantity will also be do for me for the analysis. So basically we do either the air sampling, solid sampling, and then the liquid sampling. See, step involved in case of a bulk step involved in the case of bulk materials. For example, if I suppose I have to I have to do the determination of a lead in some kind of a lake which is having an area of about say 10 square kilometer of area, and I have to tell it, what is the concentration of lead in that particular lake is there. Then from that population, I have to collect a sample, a proper sample, which is represent this 100 square kilometer of the area. And since I cannot determine the concentration of the lead in that particular place itself, so what I have to take in it, whatever the graph sample which I collected from that lake, and that graph sample should represent the whole lake. Then I convert it to smaller samples and then bring it to the laboratory, because it is to be further converted into a small packet or a bottle, so that I can bring it back to the laboratory and perform the analysis. So, what are the steps involved in this particular? Identify the population from which the samples to be obtained. Collect a gross sample that is truly representative of the population being sampled. Reduce the gross samples to a laboratory sample that is suitable for analysis. Okay. See, basically, when we are doing any kinds of liquid sample, it's very easy, because most of the time the liquid samples are a homogeneous one. But in case of a solid sample, this inhomogeneity is, is of a concern. And then it's a very difficult to make sure that the whatever the sample I am collecting is inhomogeneous. It's a homogeneous one. So inhomogeneity of the material making sampling of solid more difficult. And what is the easiest way to sample the material is a grab sampling. Grab sampling means what you take, grab means you just collect it at once, or the sample taken at a random and assumed to be representative. In certain cases, when there is no alternative, you assume that suppose if you are taken a rock of 1 kg, you have a big rock is there, having some 10 meter by 10 meters. So what you do, you can just take a graph sample out of that, or maybe collect some few random samples from different part of that rock and assume that it's representing the complete rock, because that. But when you perform, when you are submitting your results to the any authority, you have to say this word. This has been done by the grab sampling, and while doing the grab sampling, some random sample has been taken, and it is based on that thing. It is been assumed that the is represent the whole rock. And generally, it's shown that either you take the 1 by 50 or 1 by 100 part of that bulk samples. And especially, this is again a very, very important part when you talk about this larger the particle size, the larger the gross sample should be. See, basically, see, if you are doing any kind of synthetic chemistry, no issue. See, because then it is possible that you whatever the analyte is there, it's been homogeneous throughout throughout your sample. But if you take any samples from the environment or from any other matrix which has not been synthetic in nature, that most of the time the material, whatever the element this goes into this depend on this specific area. And you know that the larger smaller the particle, higher the specific area, and the concentration of that particular analyte will be more in the smaller size of the particles, because this if you study the absorption and sorption, then you understand the importance of the specific area. So in that case, generally in case of a solid sample, as well as the synthetic chemistry, as I told you, is not of much concern. But if you are of a natural, if a sample of a natural origin, as per the international protocols, one has to say that the sample has been the sample which you analyze is having a 10 microns, 20 microns, 100 microns, or 2000 microns. In general, whenever we talk about the environmental samples, see, we very critically say that the size of the particles is in the range of a 2000 microns. Okay, so the size of the particle is very important when we have a samples from the natural origin, not in case of synthetic one. Okay, but in case of synthetic also, if it had not been done properly, then the smaller the particle size, the higher will be concentration of the analyte are there. Then gross samples should be must be reduced to size in obtained laboratory samples. And in most of the cases, solid sample needed drying, because if it is a wet one, then see, the reporting of the results is very important. See, the reporting of the results it has to be very categorically told. This has been done on a dry basis. The analysis has been performed on a dry basis. Again, some of these parts are very irrelevant when we talk about synthetic chemistry, but if it is sample of a natural origins, then the reporting has to be done on the basis of the particle size as well as the moisture content in the samples. Okay. Then comes over the air sampling. See, air sampling, there's a different way of doing the air samplings are there. So in general, it can be used a flask, bottles, or a bag. See, generally the bag which we use for the air sampling, and then performing the analysis of the bag of that particular gas in the laboratory. So we use the Tedlar bags. Okay, so in the Tedlar bag, there is a proper arrangements are there. So you can attach with the help of a pump, and then you can suck the gas and then fill this particular bag and then bring that particular volume to the laboratory and perform the analysis. Then consider this CC as a gas. It's not only considered as a air then it contains so many particles also there. So there we perform this high volume air samplers are there. And there's a two kind of high volume samplers are there. One is called a PM10. PM10 means see, basically, these are the air samples which is based on the cyclonic based air samplers are there. So it's having a 10 microns mean PM10 means that the it do the there's a classifier filter paper is there, the particles which are less than 10 microns. I do not know whether how many of you dealing with the environmental chemistry. See what are the whatever the air which we inhale it. See, you have seen that most of the time in the various news item that PM10 or PM2.5 nowadays we are telling it these are the particles concentration of PM2.5 or PM10. See, these are the particle which we inhale it. Actually, maybe the gases, these suppose whatever the our inhalation rate, I think I don't remember right now. So this is the inhalation rate with that volume we are inhaling. These many particles are there, and these particles basically having a size of either of 10 microns or a less than a 10 micron, less than 2.5. So these are the high volume samplers are there. They are cyclonic based high samplers are there. On the top of it there is a glass fiber filter paper is there, and then the particle less than the 10 microns will be sit on this will be collected on the filter paper, and then there is a collection water is there. More than 10 micron they will be collected on this, and less than 10 micron particle will come on this bottles are there. So this is how we do this, use the high volume sampler and the collections of this dust. And there are the cyclonic based dust samples are there. And then there is some liquid displacement techniques are there where that we can use different liquids, but only this that condition is that the sample must have a latent solubility in that liquid and does not react with that liquid. That gas should not react with the liquid. Generally, we use water as a solvent in case of collecting the various gases. And for example, the breath samples, the subject should be evacuated. See, when you are doing the breath sampling, your breath should be blow and into a evacuated bag like toddler bag. I told you, toddler bag, which you can use it for this collection of these things. As I told you, that liquid sample is much easier because these samples are relatively small, and if liquid samples are not homogeneous and have only a small quantity, they can be shaken and sampled immediately. And the sampling depends on the type of liquid. A large volume of liquid for which is impossible to mix. Large stationary liquid like rivers, lakes and rivers, and then different biological fluids are there. So depending on the what kind of a matrix from which kind of a matrix you are taking the liquid samples, so it will your sampling methods will be vary. And see what I consider for this for this 6 lecture, you can use these books. You can use this Cook and Hollis. Then instrumental method of analysis by Dean Merritt Willards, and quantitative analysis by Day and Underwood, and definitely this qualitative analysis which we are reading from our ninth class, that is Vogel, still is a viable. So most of the things regarding this analytical chemistry you will get it into this one, but definitely some of those things are still will not be covered on those books. For that you have to take some of the few references, or you can my email ID is given to you. Anytime you can ask me any questions. I think this lecture will be available on the YouTube also, so you can see that lecture again on the YouTube, and then you can come back to me for any kind of queries, because during the course of the lectures I may not be able to explain you some of those things which I make it very very clear when you ask me very specific question to me. For example, the boy asks me this robustness and the ruggedness. See, there are, I think maybe I taking more than 600 lectures up to now. But this question had been maybe asked me the first time only. See, ruggedness or the the robustness of a technique. Okay. So, but it's always, nice because some of the words you will pick up and then ask me question, then it's really, able to answer you better way. So with this, if any questions are there, please ask me, and please do not hesitate to ask me any questions actually. Okay. Because no question is silly, and maybe there is some may not be I may not be able to explain you properly. So I'll try to for that specific portion I'll take some more time and explain you nicely. See, during all my lectures, always I have stressing of this need. Even if you understand 5 minute lecture, pick up some few words is very important. And what is the importance of the today lectures? I think if you had considers this methodological flexibility, that's very important. The methodological traceability until see if you given any sample to for the analysis, you must ask him whether a standard reference material had been tried. See, the number which is given to you is a correct one or not. How the analyst has to assure you that the number which is given to you is a correct one or not. Okay, because what he is doing the processing and the analysis is done by the instrument only. So there is a many way of introducing error in the samples analysis. So it's very important to perform a QA/QC on the any analytical results are there. Anything? Yeah. एक्चुअली में क्या होता है ना आमने सामने बैठ के लेक्चर देगा ना तो काफी अच्छा रहता है सी until unless you will come to know what their